Let's talk about multithreading in modern C++. What is multithreading? Why is it so important? And how it all works? So multithreading was introduced with C++ 11. And prior to that, if you ever wanted to work with threads, it was so hard and there were so many issues and problems. But now in modern C++, there's a very easy way to work with threads. Before starting to code, I'm going to talk about what threads are. Primarily, threads are used for speeding up our program, and they're used for optimization and also to do different things at once. So like, multi-threading is the concept to this. So multi-threading and multitasking are two different terms, and sometimes they're confused by many. Multitasking is the ability to do one task and then do the other by moving to that task, but not necessarily doing it in parallel. Whereas in multi-threading, you are doing two tasks at the same time. You're doing it in parallel sequence. So that's different. So multitasking we do all times. So like humans do multitasking by, like, for instance, I'm writing code right now, and then I get a phone call, so I pick up my phone and answer the call. So I'm switching my task from writing code to picking up a phone and talking. So I'm basically switching my task, and I'm not doing the same task at once. Whereas in computers, they do the same thing, but they do it an extreme time that you can't even notice that they basically switch from the task. But that's multitasking. In multi-threading, they could do both things at once, so they don't need to switch anything. They have cores that are used for different applications. So part of that is used for some purpose and the other part is used for the other purpose. So multithreading is the general ability of multiple parts of one program to be executed at the same time. So far, all of the code we've been writing in our series was on a single thread, meaning executing the code one instruction at a time. Mostly all the things we've been writing didn't need to be fast or well optimized or quick. It's just been some simple stuff what we've been doing. But as we go into more complex problems, it'll be very beneficial for us to actually move off certain work to two different threads of execution. Repl.com, and over here I'm gonna click on C++. And why I'm using C++ here is that they basically provide you with the most latest version of C++. So you just write it out in browser. So I'll put the link in the description to Repl.com, although they didn't sponsor me or anything, but I'll put this so that you could go and try this out. So over here we could just change this to say, let's say sample code. So now I create the Repl, and this basically redirects me to my Repl page. Over here we have the sample code here, and we have basically the main.cpp here, and this is our file. So what we could do here is we basically have a boilerplate which is already provided. Hash include iostream and int main, and we have a hello world program. Here let's create a Repl thread. So to use threads, we have to include the thread header file. So we basically include this. So once we do this, we included the thread header file. Now let's use some threads. So I'm going to create a function here, and it's going to be called, let's say it's going to be called func1. And what func1 is basically going to do something, write a for loop for this program. So let's have int I is equal to 0, and we could go all the way to, let's say, 100, and we could say I plus plus. And now we know that this is going to be starting from 0 to 99. And we could say standard cout, and we'd have the ith value, and we could say standard, or we could just have a space here, so like that. Now this is going to run for 100 times, and then once it's done, it's just going to break out the code. We don't need a return type here. I'm going to invoke this function using func1 and just call it like that. If I do this and I invoke the function and run the code, you can see over here it would be printed 0 all the way to 99, and then after that hello world obviously comes because of this code over here. So we could just remove this portion here. Now after this, we want to do this executed in a thread. We want to do it in a single thread. How do we do this is, first of all, let's create a thread. So we could say standard thread. And once we do that, we could basically have a name for this thread. So we could call this as worker. And inside of this, we could pass in our function. And this thing, what we're passing in, is called a function pointer. Now, the function will perform on a different thread of execution. So it's basically takes a function pointer as a parameter. That's why we basically pass in this func1 without parentheses, no parentheses in here. So now when we run this, basically what we have to do now is instead of calling the function, we call the thread. So to do this, we could essentially do something which is basically calling like that. This is how you call the function thread. And after this, we could just run the code. Now over here, you can see the terminate call without an active exception. This is occurring because we don't have some kind of finish point here. So the finish point here we have is worker.join. And I'll tell you what this means. So once we do this, we basically have our code executed. Here we have 0, 1, 2, 3, 4, 5 all the way to 99, and this is basically telling us that it's done. So if I run this hello world after this, so this was in one thread and then hello world was in a separate thread. To see the difference between threads, we could use a function which is called, I can also print the thread ID I'm on. For instance, I could print here standard cout, and I could print out this thread ID. So I could say, for instance, thread, and then we have ID and colon. And now we could put in this syntax here. So it's standard, and then we have this underscore, wait a minute, not caps, this underscore thread, and then we can have, after this is the get ID. So get underscore ID function, and we could have a standard colon colon end line. So right after this, we could get the thread ID for this. And I could just copy this code, and I could just print it right after this portion. Because what happens here is that this portion here, this join, this won't let us proceed this statement here until the worker thread, which is this one, worker thread, until the worker thread has completed its execution. So yeah, so it won't let it, and then this is the main thread, so this will be a different ID. So let's run the code. And now you can see over here we have thread ID, and we have a different thread which is 720 at the end. And then we run our thread, so our thread is running. And then once it's done, we basically go after the join and we print out the other thread ID, and this is 20. So you can see that there's a difference over here. This is 120 and this was 720. So this is after that hello world executed. We could actually have our format a little better by putting a \n over here, and now it looks much better. So yeah, it looks much better now. So we have this and then thread ID over here. We could also change up the way how this is working. So for instance, I could have an end line here. And the other thing what I could do, actually I need a standard, so standard end line. And the other thing that I actually need to do is that I could put some time. After that, I could actually have it stop for 1 second. So I could say standard this underscore thread colon sleep for 1 second. And for that one, I have to include a namespace. And basically the namespace could be included here, or we could actually include it right in here in this function, which is much better. So right here. And now we could run the code like this. And now you see that it basically is stopping, and you know it's like ticking every 1 second. So every 1 second you're getting a new number. And once I press like, basically it's gonna go all the way till 100, and after that the next thread will execute. So this is actually a pretty long. What I could do is I could change this up. So let me just cut this program here, Control C, to terminate the program. And I could like clear this. Actually it's a bash, I think so. So I could just clear using clear. Okay, so now I could change this number up. So we could have it, instead of that, we could have it 5. So now let's run the code, and you'll see that this thread will execute. And once after that, the join is done. So after that, this thread will execute. So we'll see some kind of instance here. So run the code. You'll see that the number 0, this thread is executed 08. So 1, 2, 3, 4, 5. Right after that, next thread is executed, which is 1, 4 is this thread. So after that, it just prints out hello world and the rest of the code. So the point of this video is to teach you how to access threads in the C++ API. If you got something out of this video, then always remember to like the video. Until then, peace out.